everyone, I am Dr. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on concept of impedance and concept of admittance. So first here, what is meant by impedance? Impedance means same thing here like resistance R equals to V by I, Ohm's law. V is directly proportional to the I, V is equal to IR. But here this is for DC case. For AC case, the ratio of sinusoidal voltage to the sinusoidal current, AC voltage to the AC current is known as that is impedance. Or this is resistance means DC voltage to the DC current. So it is also defined as opposition of which opposes flow of AC current, that is sinusoidal current, which opposes the flow of current. Hence, impedance is measured in the resistance same unit as ohms, and the real part of the impedance is known as the resistance, and imaginary part of the impedance is the reactance. Here, impedance is represented with Z, and Z equals to R plus JX. Here, J notation I will explain in the next slide. J is the impedance and R is the resistance and JX, X is the reactance. This is the real imaginary part and this one is the real part and this is the impedance. Now here the units for resistance, reactance and impedance is same, that is ohms, and Z equals to R plus J. Here reactance may be either inductive, X may be either inductive reactance or capacitive reactance, XL or XC. Z equals to R plus J XC and Z equals to R minus J XC. This is series resistive resistor and inductive case, inductive reactance, and this is for capacitive reactance. So now Z equals to R minus J XC. So now if you take the magnitude, Z equals to square root of R square plus J XL, and that angle is that one equals to tan inverse XL by R. And next same way here for in RC circuit, this is for RL circuit and this is for RC circuit. Square root of R square plus X square at an angle of tan inverse X minus of XC by R. So for resistor, inductor, capacitor case, so Z equals to R plus J XL minus C XC. If XL minus XL is greater than XC, this one, and Z equals to R square, square root of R square plus X square. This X may be XL minus XC and tan inverse X by XR. If it is XC is greater than XL, so for that case, so now here XC minus XL you can substitute here. So now here, what about the impedance triangle? How you will draw the impedance triangle? So now here this is the diagonal. Let me change the color over here. This is here. This is the impedance triangle. This is Z, this is the R, and this one is the XL, and this is the theta, power factor angle phi or theta. And now here this here cos phi equals Z equals to, this is J notation, Z equals to R plus this R plus J XL. J XL 90 degrees. J indicates 90 degrees rotation. And next here theta equals to tan theta equals to XL minus XL by R. So now here cos theta is the cos phi is the power factor that equals to R by Z. Theta equals to tan inverse XL by R. This is for inductive reactive RL case. So what about the XC case? XC case, this is the case. So this is Z, this is theta, this is R, and this is the XC. For this case also same formula, Z equals to R minus J XC. Same formula, theta equals to tan inverse XC by R. XC by R. Now here. Now what about this case XL minus XC? So for this case XL is greater than XC, this one, but this is XL minus XC. And for this one XC is greater than XL, this one, for this case XC minus XL. So now this is impedance triangle. Impedance triangle. So now here, so J notation is the J notation. Z equals to R plus J XL. XL R minus L. So what is meant by this J notation? Here, J notation means J operator is a vector. When it rotates, when it operates on the phase, produces a counterclockwise rotation of phasor by 90 degrees without changing the magnitude. If it is a Z R and this is an X. So now here, without changing the magnitude, it should not be here. So rotating and in anti-clockwise 90 degrees. This is Jx. So and this is Z. Z equals to R plus Jx. So now here, next thing here, this is Z notation. Here this is the diagram. So 1 here. So anti-clockwise plus J multiplication. And if you multiply with 1 again, plus J into and plus J again, J square. So this is the J square. So J square equals to minus 1 or J equals to square root of minus 1, this one. And next minus 1 into plus J again. So next minus J, that one, and minus J into again this J 90 degrees and J. So that is equals to minus J square, that equals to minus J square minus into minus 1. So that equals to 1. So now first it is 1. So multiply with, if anti-clockwise rotation 90 degrees plus J and anti-clockwise 90 degrees again multiply with plus J into plus J. J square means that is minus 1. J equals square root of minus 1, that is minus 1. That is 90 degrees. And next again anti-clockwise rotation 90 degrees. So now minus 1 into plus J, and that is minus J, and again 360 degrees. So this is minus J, this minus J into plus J, that equals to minus J square minus and minus of minus 1, that is plus 1 again. So again 90 degrees. This is J notation. So here if you write here 0 degrees case or 360 degrees case, so that is plus 1 at an angle of 0. This is polar form and this one is a rectangular form. And 90 degrees case here plus J, that is J equals square root minus 1. So now this is polar form, 1 at an angle of 90 and 0 plus 1J, 0 plus 1J, and at minus 90 degrees case this one. So minus J 270 this one, and this is 270. So minus of minus 1, this is minus J, 1 at an angle of minus 90, 0 minus 1 this one, and plus or minus 180 this one, square root of this is minus 1. So 1 at an angle of plus or minus 180. So minus 1 plus J 0. This is regarding J notation. So now here reactance. What do you mean by Z equals to R plus Jx? So resistance which opposes the flow of direct current. Now what about the reactance? Reactance means here J notation already we discussed and impedance is okay. What about the reactance? Reactance in electrical and electronic systems, reactance is the opposition of electrical circuit to change in the current or voltage due to the elements. What are the elements? Due to the inductor and capacitor. Due to the elements inductance and capacitance. So there may be a opposition of current, electric current. So such property material is known as a inductive reactance or capacitive reactance. Reactance is measured is also already we discussed. That is units. Z impedance units resistance ohms, resistance units ohms, and impedance units ohms. So but it is given the symbol is X. So now here for pure resistor case this value is 0. Now here as a if it is a inductor is added, so that is inductive reactance Z equals to R plus Jx. If it is pure resistor case, this impedance is 0. If it is RL case, so this is R and there may be having inductance. So X equals to 2 pi FL, that equals to omega L. Omega means 2 pi FL. So now here, So this is the inductance. XL equals to omega L. Omega means 2 pi. This is omega 2 pi FL. So this is inductive reactance. What about the capacitive reactance? So capacitor charges or discharges. A current flows through in it. So now here, which is restricted by internal impedance of the capacitor. So that internal resistance is commonly known as the capacitive reactance, that is represented with XC, and units are ohms here. So now units are ohms means here XC equals to, so this is the capacitor symbol. In the capacitive reactance equals to 1 by omega C. Omega means here 1 by 2 pi FC here. So now here the representation of rectangular or polar forms. So how you will calculate? So now here this is the, so now this is a representation. Any polar quantity, any alternating quantity in representing different ways. So most popularly known forms are rectangular form and polar form. So these are okay. Trigonometrical and exponential. In our electrical circuits, we will use rectangular form and polar form. So rectangular form is also known as the Cartesian form or complex form. So sine waves, AC waves can easily expressed in the phasor form, which are more convenient to work with sine and cosine functions. Phasors in the complex form can be represented polar and rectangular forms. Polar form and rectangular forms are most important. So polar form is Z equals to X plus jy or X minus jy, and Z equals to R at an angle of theta. So these two are most important, and these two are is also okay. Z equals to this is a trigonometrical form. Z equals to R cos theta plus J R sin theta, and this is Z equals to R e power plus or minus j theta. So now if you take the one phasor, this is the alternating quantity, that polar form X and Y, and this is 0 comma 0, and this up to here this value is X, and up to here this value is Y, and that angle is theta. Now this is the R and this one is A. Now here this is the R. So R is R value. So now here R equals RZ, you represent it is Z. So Z equals to X plus JY. So this is R1 and 90 degrees rotation. So now X plus J is the notation. If it take in 90 degrees rotation, so that is 90 degrees, that means that is JY. So now this is polar form, and this is the polar form, and how we will take the Z equals to R at an angle of theta. So now here R means here this representation, this is R. If it is suppose R equals to R square, if you apply the Pythagoras formula, R equals to X square plus Y square. So now here X square plus Y square. So this one, and theta equals to, if you have theta equals to tan inverse Y by X. So this theta equals tan inverse Y by X. So now here X equals to, this X equals to R cos theta, and Y equals to R sin theta. If you take this triangle, and this one is a theta, and these two are sides, and this one is a horizontal diagonal, if you apply. So now here Z equals to this one equals to R cos theta plus J sin theta, and another form is R at an angle of theta, R e power plus or minus theta. These are the polar forms and rectangular forms. So if you can convert from polar to rectangular, so Z equals to X plus JY is a polar rectangular form, and Z equals to R at an angle of theta. This is the polar form. So now here you can convert from polar to rectangular and rectangular to polar. So now here theta equals to tan inverse Y by X, and R equals to square root of X square plus Y square. So this is the polar to rectangular form. So from the rectangular to polar, you can polar to rectangular also you can convert. But X equals to R cos theta plus Y equals to R sin theta. This is the diagram. From this diagram also you can write the formulas. No need to memorize these formulas. And next thing here, So these formulas, so now here this is most important for pure resistor case, pure inductor case and pure capacitor case. Voltage and current both are in phase, and for pure inductor case, voltage and current lags voltage by 90 degrees. Sorry, this current lags voltage by 90 degrees. Current lags voltage by 90 degrees, and this is the pure capacitor case. This is the current leads voltage by 90 degrees. You can you can tell like this. So voltage leads current by 90 degrees. Voltage lags by 90 degrees. This one and this one. So this is the pure resistor case, and this one is the sine wave. So this is Z equals to R plus J0, and this is the pure inductor case. So there is no inductance, so there is no resistance, means J omega L, so XL, and next minus J omega C. This is for pure capacitor case. This is one is the AC circuit. So now these are polar forms. So convert into rectangular form. Sorry, these are the rectangular forms. So convert into the polar form. Z, if you take the R equals to square root of R square plus 0 square. So that formulas, and tan inverse 0 by R. So these formulas if you apply. So now this is the polar form. Z equals to R at an angle of 0. Z equals to XL plus 90 at an angle, and this one XC at an angle minus 90. So this is the one, this one is the 1, and this one is the 1. So this is regarding pure resistor case, pure inductor case and pure capacitor case. So now what about the formulas for pure, these are the pure resistor case. So what about pure RLC circuit, RL circuit? So R and L connected are series, and the entire circuit is connected across the supply. So that is AC supply. So now for that case, Z equals to R plus JX. So here there is a inductor. So now for that case, not 90 degrees. So now for that case, that there may be a voltage and current, not exactly 90 degrees. So current lags voltage by some angle phi. So that angle phi or theta. So that is theta. In the previous case, there may be a 0 angle. So now here Z equals to R square plus JX square. So now here tan inverse XL by R. So current lags voltage by some angle. That angle is theta. For the same way for R and C capacitor case, here for the capacitor case here RLC. So now here this is R and this is the C. And that means XC, this is the voltage and this one is the current. Here Z equals to R minus JXC. XC means 1 by 2 pi FC, that means 1 by omega C, and Z at an angle of theta, Z equals to square root of R square plus X square. So now tan inverse minus XC by R. So already we have seen that vector diagrams and impedance triangle for RL circuit and RC circuit and RLC circuit, and here current leads by, so this is the voltage and current leads by some angle, not exactly 90 degrees like this, that angle at between 0 to 90 degrees. So this is for now. This is for pure resistor R, this is for pure inductor, and this one is a pure capacitor. Current and voltage are both are in phase. Voltage and current. This is the voltage and current. Voltage magnitude is higher than current, and next angle is 0 phase angle, and this one phase angle between these two, voltage and IR T equals to IR sine omega T, and for capacitor case, so that there may be some angle. So this one minus phi. So voltage and current. So this is the voltage waveform and this one is the current, that angle is minus. So now here for this case, capacitor case, there may be leading. So this is the phi. So this is the current. So this is the plus phi. So now here pure resistor case, pure inductor case, capacitor case, RL circuit, RC circuit, and series RLC circuit. So this is the polar form and rectangular form. R at an angle of 0, R plus J0, XL at an angle of 90 plus 0 plus J0, and XC at an angle of minus 90, and 0 minus xc and z plus and r plus jxl and z at an angle of minus 5 and r minus jxc, and this one is RLC circuit. So the phi is 0 here, 90 minus 90, and between 0 to 90 and between minus 90 to 0, and this one is some phi depending upon the RL reactance magnitudes. Power factor is 100 cos phi and cos phi. Here remarks for this one: this is pure unity power factor, lagging power factor, leading power factor, lagging, leading, and if it is XL is greater than XC, that is lagging, this is lagging, leading, and this one is next. So for this is a polar form, rectangular form. If you convert into the polar form. So for addition and subtraction, most of the many cases we will use rectangular form. Addition and subtraction for multiplication and division, and polar form we will use. So keep it in mind. So for in the calculations, find out the resistance and inductance or capacitance, impedance offered by frequency 25 at an angle of 45. So 6 plus j8, 8 minus j10. So now Z equals to, what is the here? Z equals, this is polar form. If you convert into the rectangular form, you will get the resistance and reactance. So Z equals to, this is the R and this one is the theta. X equals to R cos theta and Y equals to R sin theta. So this is 25 cos 45 and 25 sin 45. So this is 25 R cos theta and 25 sin theta. And this one is 17.68 and 17.68. So this value is the resistance. This is the resistance and this one is the reactance. So now here this one is also same, comparing. So now here this is reactance, means that is 17.68. So now here L 2 pi f, f is a 50. So now if you substitute in this, you will get the inductance value. Resistance this one and this one is the inductance value. And next, what about this one? Same thing here, 6 plus jxl, this is the R value, directly R value, but this is the XL, so XL is 8 and this one is the 50, this is the inductance. Same fashion for this one, this is the R minus jxc, R value is 8 and xc is 10, so xc equals to 1 by 2 pi fc, c equals to 1 by 2 pi fc, means here f equals to 50 and xc value is 10, this one. So now here 3.18 into 10 power minus 4 farads, that equals to 318 microfarads. Next, what about the admittance? Admittance is defined as a so it will allows the flow of current. So impedance, it will opposes the flow of current, and but here admittance, it will allows the flow of current, that is AC current. So now here in the parallel circuit, inverse parameters will useful for this analysis. Inverse of impedance is known as a admittance. Impedance opposes the flow of current and admittance allows the current. So now here for that case Z, so it is represented with capital Y. So now Y equals to 1 by Z. So it will opposes and it will allows Y equals. The reciprocal of impedance is known as the admittance. The now here the ratio of current, here impedance means Z equals to V by I, but here Y equals to I by V. So now here this is the diagram. So now Z equals to R plus JX, this is the impedance in ohm, R is the resistance and X is the reactance here. So now Y equals 1 by Z, that equals Z inverse 1 by R plus JX. So now if you rewrite this one, so now here R minus jxc and x by and R minus jx, multiply with R in the numerator and denominator, R minus jx by R plus R minus jx. So there is no change in the numerator and denominator, and this one if you multiply a plus b into a minus b, R square minus j square xc, j square means minus R square plus x square, this one. So now here in this Z equals 1 by Z, R minus jx by r square plus x square. So this r minus jx and this one r by r square plus y equals to r square plus x square minus j by x by r square plus x square. This is known as a conductance. So this units are ohms, and this is known as a susceptance, that is units are mhos, that means Siemens. And impedance admittance units are also mhos. These units are mhos, that units are mhos. So we can we can call it as a Siemens, or you can write here like this. So admittance, susceptance, and conductance. So now here if you draw the this is for admittance triangle. Previously we have drawn the impedance triangle. This is the admittance triangle. This is G is the conductance, B is the susceptance, and this one is the G plus JB. G plus JB equals to Y. Admittance, conductance, and susceptance. Y equals to GC minus JB, and Y equals to G square plus JB square under root tan inverse B by G. Calculate the impedance and admittance for a given circuit below for 150 ohms. Here this is L and this one is the R, and this one equals to XL equals to this one. So F equals to 150 ohms and L value. So substitute in this 150 ohms and L value is 0.8. So now this is J 2 pi 5. This one equals to 2 pi, 2 into 3.14, and this value equals to J 754, and Z plus R plus JXL. So this one the Z 754 J plus 250 this one. So that if you, this is the polar form, and if you convert into the this is the rectangular form, convert into the polar form, that value equals 796 at an angle of 71.7, and that admittance equals to, for addition and subtraction use polar form, for multiplication and division use rectangular form. Multiplication and division polar form, and plus and minus addition and subtraction use rectangular form. For sine wave, for a coil, solenoid coil was found to have static resistance 12 ohms measured with multimeter. If solenoid coil draws 5 amps current, so now when it is connected to 100 volts and 1000 hertz supply, calculate the inductance of the coil and power. So now here this is the R value, and what about the frequency value? This is the current. So now here current value Z equals to V by I. We know this formula. So now here this 100 volts V by I is known as the impedance. V by I is known as the impedance. This is the R. So now here V equals to 100 and I equals to 5, R equals to 12. We know this formula, and F equals to 1000. So now here V by I, if you do the V by I, you will get the impedance Z. So Z value you will get 20 ohms and R value is 12 ohms. So from this you can calculate the reactance value. So reactance means Z square minus R square, and 20 square minus 12 square under root, that equals to 16. So now if you know the reactance and frequency, so now then you can calculate that this is the reactance 16 by 2 pi 1000, that value equals to 25 millihertz. So now what about the power factor? Power factor, from the power factor, this is the triangle Z R plus X. So this is the 16, and this one is here 12, and this one is 20. So now here R by Z. So this theta equals to tan cos phi. This is the power factor equals to cos phi, that equals to R by Z, that equals to R by Z means here 12 by 20. So directly you can write. So no need to do, Z equals to 20. So 20 is here. So now here a non-inductive resistance of 10 ohms, a capacitor 100 microfarads and 0.15 henries are connected in series to 240 volts 50 hertz supply. Calculate the inductive reactance, capacitive reactance, and circuit complex impedance and power factor. So now if this is the resistance R, and this is the inductance, and this one is the capacitance, and 240 volts supply. So now here, so now inductive reactance 2 pi FL. So frequency value is 50 Hz, 2 pi F is 50 Hz, and L. So this is the inductive reactance, and F and C. So F and C inductive capacitive reactance. Complex impedance means Z equals to R plus J XL minus XC. So if you write the magnitude, Z equals to square root of R square plus X square, X equals to XL minus XC. So now this is the XL and this one is the XC, and R equals to 10, that value is 18.3. Power factor equals to R by Z. So this R by this Z value. So now here, power, what about the power? So power is here average power, next here complex power. So average power is divided into 3 parts: active power, reactive power, and apparent power here. So now here power is rate at which is done, so that rate of energy transfers. So now here if you write the power equations, power triangle, then you will get this is the apparent power, and this is the active power, and this is the reactive power. This is represented with P, and this is represented with Q, and this is represented with S. This is units are kVA, these units are kilowatts, and these units are kilovolt kVAR. So kilovolt ampere reactive. So now here power factor equals to this apparent power, cos phi equals to this apparent power divided by, so this active power divided by apparent power, or P by S, or kilowatts divided by kVA. Okay, now here, so now here for this RL case, this is lagging power factor, and for RC case, this is leading power factor. So power triangle already we discussed. So now a wound coil, it has a inductance, this one 150 millihenries, resistance 25 ohms, and 110 volts 50 Hz supply. So calculate the impedance of the coil, current, power factor, apparent power, and draw the resulting power triangle. So now here impedance equals to R plus JXL. So R plus JXL means 2 pi FL. So this is the frequency, and this is the L value. So now this is the frequency. So that value is 47.1, and Z equals to square root of R square plus XL square. So that equals to 25 square plus, so the under root. So 47.1 square, that equals to 53.32, and that impedance equals to 53.2. So this is the impedance. So now here current equals to voltage by impedance. So we know very well this one. So 110 volts divided by impedance, that equals to 2.6 amperes. So now what about the power factor? So power factor, if you draw the Z R plus X, so this is the phi. So phi equals to R by Z. So this R value is 25, and this one impedance is Z equals to 53.32. That power factor equals 0.46, and that angle equals to 62. Cos phi equals to 60. Cos inverse of 0.46, that value equals to 62.4. And next, what about the apparent power? And cos phi means 0.46. For what about the sin phi? If you know the cos phi, you can calculate the sin phi. So now Vi cos phi and Vi sin phi active power, this is the reactive power. And what about the apparent power equals to V into I. So this is the P, and this one is a Q, and this one is a S. So V into I into cos phi, V into I into sin phi, and V into I. You can write here, this one equals to V into I, that equals to 110 into 2.06. So that, or you can write here, if you know the P and Q, then you can write this is a right angle triangle. So you apply Pythagoras formula, then you will get this one. This is the apparent power, this one is the active power, and this is the reactive power. I hope all these concepts are clear to you, admittance and impedance. If you still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.